Differential equations section 1, tangent fields. Video 5, tangent fields worked example. In the previous videos, we've looked at what a tangent field is, how solution curves fit onto the tangent field, and we've seen what isoclines are, lines joining areas that have equal gradient. Let's work through an example that joins all of these things together. So for the differential equation, y dy by dx equals x, sketch the tangent field, sketch the isoclines, and sketch the solution curve passing through 0, 1. Well, before I look at this in Geogebra, what I want to do is I want to rearrange this so I've got the differential equation in the form dy by dx equals. So, rearranging it, I need to divide through by y, so I'm going to get dy by dx equals x over y. Now I've got my derivative as a function of x and y, so I can have a go at plotting it in Geogebra and seeing what the tangent field looks like. So first of all, I'm going to define my function f of x and y equals x over y. And then I want to start by plotting the tangent field. So I want the slope field of f. And again, I'm just going to put slightly fewer so that it's going to be easier for me to copy it down. And then I'm going to move the grid around a little bit just to get a sense of what that slope field is doing. And I'm seeing that if I look along the x-axis, all of my little lines are vertical. And moving it along like that. Along the y-axis, all of these gradient lines are horizontal. And then they're making these sort of curved shapes here with, along this line y equals x, it's looking as if my gradient is 1 all the way along that line y equals x. Okay, let's try and get that down onto our grid then. So here's my sketch of the tangent field for y dy by dx equals x, which I've rewritten as dy by dx equals x over y. So thinking about what's happening on the two axes, well, in the case where x equals 0, dy by dx equals 0, so that means that on the y-axis, the gradient is 0. Thinking about what happens when y is 0, well, think back to what we did when we were looking at derivatives, and that's explaining to us why the tangents are all going to be vertical along the axis. And then if you consider what happens when y equals x, dy by dx equals 1. So that's why we've got this gradient of 1 going along the line y equals x. When y equals minus x, you're going to have a gradient of minus 1. So that's why I'm getting this other diagonal line going down here. And then in between, I've just tried to draw the shape of these curves going round to represent the tangent field. Now the next part of the question invited me to find the isoclines, so the lines where the gradients were horizontal, vertical, and have derivative 1. Well, I've just seen from my tangent field that the gradient is horizontal on the y-axis, the gradient is vertical on the x-axis, and the gradient is 1 all the way down on the line y equals x. So here's my drawing showing those isoclines. So I've got y equals x there, I've got y equals 0 there, and I've got x equals 0 here. So that horizontal gradient was 0 on the line x equals 0. It was vertical on the line y equals 0, and it had derivative 1 on the line y equals x. Now the last part of this invited me to sketch a solution curve, so going back into Geogebra, I wanted the solution curve that passed through 0, 1. So let's set up a point A. And then I want to solve the ODE with F passing through A. And there we can see the solution curve. So I'm just going to zoom in a little bit and get a sense of the points that it passes through. I know it passes through A. I can see that it's just below 1.5 when x is 1. I can see that it's about 1.75 when x is 2. And by getting some of the sense of the shape of the curve and how it relates to the tangent field, I'm going to have a go at sketching that now. So here's my sketch of the solution curve. I've just copied down some of the points from my diagram and used it to get a shape of it. And here are all of those things drawn on the same grid from Geogebra for you so that you can see how it all relates together. I've got the 3 isoclines drawn on in red. I've got the tangent field plotted there, and then I've got this particular solution curve just here. In this video, you've learned how to solve a problem which combines tangent fields, isoclines, and solution curves.